Fedora Linux 41 has been released. This new version brings some exciting updates and a better user interface that makes it easier to use. It includes the latest DNF5 package manager and the GNOME 47 desktop environment, which both add to the overall experience. In this video, I will show you how to install Fedora Workstation 41 with full disk encryption, along with Snapshot and rollback support. So if you mess up the system settings, install something that does not work, or run into problems after updating, you won't have to worry about breaking the system and spending hours trying to fix it. Simply restore the snapshot before the problematic change, and you are good to go. If you're looking to set up Fedora with either the KDE or XFCE desktop, you can also watch this video. I will show you any changes that need to be made for the KDE or XFCE desktops. In my previous video on installing Fedora 40 with full disk encryption, I chose to use the command line interface instead of the regular Anaconda GUI installer. The reason for this decision was that the Anaconda installer does not support encrypting the boot directory, which is an important step in the installation process. However, I have found a way to encrypt the /boot directory while still using the Anaconda installer, which I will show in this video. For this guide, I will use a hard disk with a capacity of 128 gigabytes. I will create a 600 megabyte EFI system partition and use the remaining disk space to create a Linux partition. I will then encrypt the Linux partition using LUKS, and following that on the encrypted LUKS partition, I will create a Btrfs file system. The Fedora also creates a swap on ZRAM during boot, so no separate swap partition is required. I am not going to create a separate boot partition because I want the boot directory to be part of the system root. So when you undo changes between two snapshots or roll back a snapshot, the boot directory and system root are both rolled back. This eliminates kernel mismatches with the reverted system. Then on the Btrfs volume, I will create subvolumes for these directories. Some directories contain temporary files and caches. Others contain data that you do not want to lose if you roll back the system root. And some should be in read-write mode when booting into a read-only snapshot. So let's get started. Boot your system using the Fedora Workstation 41 installer. On the welcome screen, select the Not Now option to return to the GNOME desktop. By default, the Anaconda installer does not support encryption of the boot directory, so you must first enable this option before proceeding with the Anaconda installer. Open the terminal window. Let me adjust the font size so that the text is clearly visible. Switch to super user mode. Open the Python script base.py, which is located deep within the user lib64 python 3 directory. Search for encryption support. Replace false with true. Save the file and exit. Next, open the looks.py Python script. Go to line 80. Copy this text. Search for this text and replace it with this text. There will be 5 substitutions. Save the file and exit. Boot encryption support is now enabled. Launch the Anaconda installer. Select your language. I will go with English United States. Next, select your keyboard language and set the time and date. I will go with the defaults. Click the installation destination option. Choose the advanced radio button, then click the done button. Here, you will create the partitions, file systems, and Btrfs subvolumes needed to install Fedora Workstation 41. First, you need to create and mount the EFI partition. Click the plus button to create a partition. Set the partition size to 600 megabytes. The file system, take EFI system partition. I will label it as EFI. And the mount point to /boot/EFI. Press OK to create. Then you must create a Btrfs volume on which you can create all of the subvolumes needed to install Fedora Workstation 41. Select the free space and click on the plus button again. I will use all the remaining disk space. Set the file system to Btrfs and the mount point to / that is root. Enable encryption by checking the encrypt option. Select looks2 as the encryption type. Grub currently supports devices encrypted with lux1 or lux2, but only with the pbkdf2 key derivation function. Lux2 uses Argon 2ID by default. We will change it to pbkdf2 once the installation is complete. Set the passphrase. Set a strong passphrase with higher entropy with at least 60 bits and higher. Press OK to create. Next, you must create a home subvolume. So select the Btrfs volume and the plus button. Enter the name as home and mount point as /home. Click OK to finish. I will create the remaining subvolumes when the installation is finished. For now, click the Done button to complete the storage configuration. To finalize the changes, click the Accept Changes button. Then press the Begin Installation button to start the installation process. The installation is now complete. Click the Finish Installation button. Please do not reboot just yet. Now return to the terminal. As I previously mentioned, Grub currently supports devices encrypted using the pbkdf2 key derivation function only. As looks to defaults to Argon2 ID, we must change it to pbkdf2. Your current installation is saved at /mnt/sysroot. First, check the pbkdf of your Lux device. As you can see, it is Argon2 ID. You must change this to pbkdf2. To change it, run this command. Set pbkbf2. I'll set the iteration count to 500,000. You can set the iteration count to whatever you want. Lowering the iterations too much reduces security. You will be asked the passphrase 3 times. The first one will authenticate, and the next 2 will set the new passphrase. Do not change the passphrase. Keep it the same as before. Check the pbkdf again. As you can see, the pbkdf has been changed to pbkdf2, and the iteration count is set to 500,000. And finally, you must enable crypto disk and cryptomount. Find your Lux device UUID. Open the grub.cfg file in the sysroot EFI directory. Insert the cryptomount command with your UUID. You have to remove the dashes. Save and exit. Open the grub file in the sysroot default directory. Add this line to enable crypto disk. Save and exit. The configuration is now complete. Reboot the system. You will be prompted for the passphrase twice. Enter your Lux passphrase. Please be aware that no cursor will be displayed, so you should assume you entered your passphrase correctly. Simply enter your Lux passphrase blindly and press the Enter key. Depending on your computer CPU, It may take up to 15 seconds for the grub to unlock. So please be patient. Enter your looks passphrase a second time to mount the root file system. Later in this video, I will enable the single passphrase prompt. The last phase of the installation process will start. Complete the remaining customization steps. You will then be logged into the Fedora Workstation 41 with the all-new GNOME 47 desktop interface. Open the terminal. Disable the grub menu auto hide feature. Next, set the Btrfs volume label. This is optional, but I will set it anyway. Volume label has been set. Check your setup. Your setup should look something like this. Then check your subvolumes. As you can see, a home subvolume has been created as specified during the installation. The machine subvolume is created automatically by systemd when you install Fedora Workstation. Install some packages. You will need them later. Update your operating system. Update is complete. Do not reboot your system just yet. There is an update that replaces the grub.cfg file in the ESP. So first, check if your grub.cfg in ESP has been replaced. You should see this cryptomount command with the appropriate UUID for your setup. If it is present, you can just reboot. If the cryptomount command is missing, it means your grub.cfg file has been replaced. So you must execute these commands first before rebooting. I will also include these commands in the description so that you can copy and paste. Since the grub.cfg file in my ESP has not been replaced, I will just reboot. I will now proceed to create the remaining subvolumes. Open the terminal. Create the directory var lib libvirt. When you install Fedora Workstation, this directory is automatically created. This will not be the case for other Fedora spins. Get the UUID of your Btrfs file system. And store it in a bash variable. Get the Btrfs subvolume mount options from the etcfs tab file. And store it in a bash variable. Now you need to define subvolumes. Go to my webpage on the same subject. I will include a link to this page in the description. And I will create these subvolumes. If you are installing Fedora for KDE Desktop, replace GDM with SDDM. If you were installing Fedora for XFCE Desktop, replace GDM with LightDM and LightVM data. Fedora Workstation ships with the Firefox web browser by default. So I will create a subvolume for the Mozilla directory. So if you take a snapshot of your home directory and then undo the changes, you do not want to lose any new bookmarks, passwords, or other user data. If you install additional web browsers, you must create separate subvolumes for them as well. If you are installing Chrome web browser, add this line to the subvolumes array. If you are installing Brave web browser, then add this line to the subvolumes array. If you intend to install the Mozilla Thunderbird email client, add this line to the subvolumes array. If you use the GNU-PG encryption and signing tool, add this line to the subvolumes array. And if you use the SSH, add this line to the subvolumes array. In this tutorial, however, I will only create the Mozilla subvolume in the user's home directory. So copy the subvolumes array and its elements, paste it into your terminal and press enter. Find the length of the longest element in the subvolumes array. In my case, it is 24. The length of this element. Go back to the web page, copy this command from 4 to done. Paste it in the terminal and press enter. And this small script will create a subvolume for each element in the array. Change the ownership of the newly created directories in the user's home to your username. If you have created subvolumes for GPG and SSH, you must also change their permissions. Like this. But since I have not created the subvolumes, I will just cancel. Check your /etc/fs tab file. This is what it should look like. Reload fs tab to mount all the subvolumes. Check your subvolumes. Your setup should now look somewhat like this. Now that everything appears to be in order, you can delete the old directories, copy from for to done, paste it into the terminal, and hit enter. All the old directories have now been removed. Well, Grub requests a passphrase to decrypt the encrypted boot files. This information is not passed on to a initram PFS. As a result, the root file system must be unlocked once more during the initram FS stage. This means that the user must enter his passphrase twice. I will show you two methods for automatically decrypting your root file system without the need for a second passphrase. Using a T file or using TPM2, choose the one that meets your requirements. If you want to decrypt your Luke's encrypted volume using a key file, then use this method. You don't need to have secure boot enabled for this to work. Change to super user. Get the UUID of the Luke's device partition and store it in a bash variable. Create the crypt setup-keys.d directory in etc. Create a key file with 4 KB of random data. The key file has to be in volume.key format. Make sure only the root user has read access to this key file. Attach the newly created key to the encrypted device's available key slot. When prompted for a passphrase, enter your looks passphrase. Add your key to the cryptodisk.conf file to include it in the init ram fs image. Make sure there is one empty space on each side. Rebuild the init ram fs image. Reboot the computer to ensure that everything is working properly. As you can see, the second Lux passphrase is not requested. It is only asked once before the grub menu appears. Bypassing the second Lux passphrase prompt using a key file is now complete. This method allows you to decrypt your Lux encrypted volume using the TPM on your computer. You must have Secure Boot enabled for this method to work. Change to super user. Make sure Secure Boot is enabled. Make sure your computer supports TPM. Get your Lux device UUID and save it in a bash variable. Enroll the encrypted volume. When prompted for a passphrase, enter the same Lux passphrase you set earlier. Verify that the TPM is added to the encrypted volume. You should now add the TPM to device node path to the kernel parameter. Run this command. and press enter. Verify that the TPM2 device node path has been added to the grub kernel parameter. You should also update the etc crypt tab file as well. Add TPM2 TSS module to the tpm2.conf file to include it in the init ram fs image. Make sure there's one empty space on each side. Update the grub.cfg file. Run drawcut to rebuild the init ram fs image. Finally, reboot the computer to ensure that everything is working properly. As you can see, the second Luke's passphrase is not requested. It is only asked once before the grub menu appears. Bypassing the second Lux passphrase prompt using TPM2 is now complete. The next step is to install and configure Snapper. Fedora 41 now uses DNF5 as its default package manager, replacing DNF4. Unlike DNF4, the new DNF5 is a fully featured package manager that does not require Python dependencies. As a result, Fedora 41 no longer includes the Snapper plugin Python 3 DNF plugin Snapper. This plugin was in charge of creating pre and post snapshots whenever packages were installed using the DNF4 package manager. In DNF5, a new way to implement this function is introduced, the Actions plugin. The Actions plugin is more powerful than the previous Snapper plugin, as it can run external applications before or after transactions and interact with the DNF5 configuration. So install Snapper and the plugin packages. Create an actions file. I will create an actions file called snapper.actions. Go to my web page copy from sudo to eof, paste it into the terminal, and press enter. The snapper actions file has been created. Create a new snapper configuration named root for the Btrfs volume @ which is the root file system. Also, create a new snapper configuration named home for the Btrfs volume @ home. Verify that the snapper configuration files have been created. And now allow regular user to use Snapper without requiring root privileges. To do so, add your username to the Snapper's root and home configurations to set a ACL. You should also add the newly created Snapshot subvolumes in the etcfs tab file. Reload the fscab file. And your subvolumes will now look like this. Disable the indexing of the .snapshots directories by update db. It is enabled by default, which can cause significant slowdown and excessive memory usage if you have a large number of snapshots. Next, enable snapshot booting. To enable snapshot booting, open the etc default grub configuration file and add this line. You must also specify the relative path option in the grub.cfg file located in the EFI system partition. Finally, update the grub.cfg file. The snapper configuration is now complete. list the snapshots for root file system. And for the home directory, at this point, you do not have any snapshots. We will create them later. The next step is to install and configure Grub-Btrfs. The Grub-Btrfs package adds Fedora Linux snapshots to the Grub menu and allows you to test a snapshot in read-only mode before rolling back to it in read-write mode. To install it, clone the Grub-Btrfs repository from GitHub. Change the directory to Grub-Btrfs. The setup is pre-configured to work with Arch Linux and Gentoo Linux out of the box. You must make a few changes to the Grub-Btrfs config file to make it work with Fedora. Go to the web page, copy from sed to config, paste it into the terminal and press enter, and then install it. You will receive the no snapshots found error since you have not yet created any snapshots. But don't worry, it will function properly after you do. Update grub.cfg file. Enable the Grub-Btrfs service. Your Grub-Btrfs installation is now complete. You may now delete the cloned Grub-Btrfs repository. Everything that needed to be installed and configured in Fedora has been completed. Now you should take a subvolume snapshot of the main volume and make the subvolume the default root file system. This allows you to roll back without having to specify the snapshot number and the ambit when using the snapper tool. So first create a directory named 1 in the .snapshots directory. Next, you should create an XML file. Go to my web page, copy from sudo to EOF, paste it into the terminal, and press enter. Ensure that the date has been set correctly and is in the coordinated universal time format, which is UTC format. Now create a read-write subvolume snapshot of the system root in the .snapshot/1 directory. Get the subvolume ID of the newly created subvolume. For me, it is 271. It could be different for you depending on the number of subvolumes you have created. Using this subvolume ID, set the newly created snapshot subvolume as the default subvolume for the system root. Confirm that the subvolume is set as the default system root. Now reboot. As you can see, there is still no Snapshots submenu in the grub. That is because, as I mentioned earlier, we have not created a snapshot yet. When we do, it will be generated automatically. Now check the snapshots in Snapper. As you can see, Snapper now displays the subvolume snapshot in the .snapshot/1 directory as snapshot number 1. The installation of Fedora 41 with snapshot and rollback support is now complete. You can now start taking snapshots. I ran some tests to determine the capabilities of the Snapper tool, as well as to demonstrate how to use it. I will add a link to this YouTube video in the description. If you are trying this out in a virtual machine, I highly recommend running these tests and any other scenarios you think of where you might want to explore different ways to destroy and recover. Although these tests were performed on Fedora 40, they are also applicable to Fedora 41. There are no changes in Fedora 41. You can also enable automatic timeline snapshots. When the timeline is enabled, a snapshot is created once every hour. Once per day, the timeline cleanup algorithm cleans up the snapshots. Automatic timeline snapshots are enabled by default in both root and home configurations. Enable it only for the system root and disable it for the home. Enable the Snapper timeline timer. And then enable the Snapper cleanup timer. That is all. Every hour starting now, a single snapshot will be created and cleaned up every other day. As you can see, 2 single type timeline snapshots have been created automatically for each hour. These will be deleted every other day automatically. If you reboot your system, and look at the grub menu, you will notice the snapshot links here as well. From here, you can easily boot into a snapshot. You will boot into a read-only snapshot. You can then easily roll back to that snapshot with read and write permission. And if you want to know how to create snapshots manually or create pre-post snapshots automatically every time you install a package, as I mentioned earlier, please look at my other video on how to use the Snapper tool. Well, that's it. This concludes the video on how to install Fedora 41 with Snapshot and rollback support. And thank you for watching until the very end. I hope you found it helpful. See you in the next video. Take care and goodbye.